Welcome to video number 2 for this unit on one-variable statistics. In this video, we're going to focus on distribution types. We can describe the shape of distributions as symmetric, skewed, bell-shaped, bimodal, or uniform. Here is a dot plot. The data set has a symmetric distribution. A symmetric distribution is a distribution where the vertical line of symmetry is in the center of the graphical representation, so the mean is equal to the median. In the dot plot shown, the distribution is symmetric about the data value 5. Here is a dot plot, histogram, and box plot representing the distribution of the same data set. The data set has a symmetric distribution. This distribution in particular can also be called a bell-shaped distribution. A bell-shaped distribution is a distribution whose dot plot or histogram takes the form of a bell with most of the data clustered near the center and fewer points further from the center. This makes the measure of center a very good description of the data as a whole. Bell-shaped distributions are always symmetric or close to it. The histogram and the box plot both group data together. Since histograms and box plots do not display each data value individually, they do not provide information about the shape of the distribution to the same level of detail that a dot plot does. Here is a dot plot, histogram, and box plot representing a skewed distribution. In a skewed distribution, one side of the distribution has more values farther from the bulk of the data than the other side. This results in the mean and median not being equal. In this skewed distribution, the data is skewed to the right because most of the data is near the 8 to 10 interval, but there are many points to the right. The mean is greater than the median. The large data values to the right cause the mean to shift in that direction, while the median remains with the bulk of the data. So the mean is greater than the median for distributions that are skewed to the right. In a data set that is skewed to the left, a similar effect happens but to the other side. Again, the dot plot provides a greater level of detail about the shape of the distribution than either the histogram or the box plot. A uniform distribution has the data values evenly distributed throughout the range of the data. This causes the distribution to look like a rectangle. In a uniform distribution, the mean is equal to the median, since a uniform distribution is also a symmetric distribution. The box plot does not provide enough information to describe the shape of the distribution as uniform, though the even length of each quarter does suggest that the distribution may be approximately symmetric. A bimodal distribution has two very common data values seen in a dot plot or histogram as distinct peaks. The box plot does not provide enough information to describe the distribution as bimodal. Sometimes a bimodal distribution has most of the data clustered in the middle of the distribution. In these cases, the center of the distribution does not describe the data very well. Bimodal distributions are not always symmetric. For example, the peaks may not be equally spaced from the middle of the distribution, or other data values may disrupt the symmetry. In the dot plot shown, the two common data values are 7 and 18. Thank you for watching video number 2 of 4 for this unit on one-variable statistics.